Hello, we've just got one starter to do today because we've got quite a lot to get through. So I've written BODMAS out at the side because we've got quite a few different things involved in this question. We've got an add, we've got an of, we've got a bracket, and we've got a multiply. So there's quite a lot going on here. So let's get rid of that. So we're going to deal with the bracket first, okay? So what we're basically going to do is replace the bracket. We're going to find out what it's worth. 45 take away 5 is 40. So what we're working out now is 12 add a half of 40 times 2. So we've done the bracket. So the of bit comes next. So we've got a half of 40, okay? So we've still got a 12. A half of 40 is 20. And we've still got our times 2. So we've dealt with the of. So the next bit we need to deal with is the multiply. So the multiply bit is the 20 times 2. So the 20 times 2 is 40. So we've got 12 add 40, so that gives us 52 as our final answer. Okay, so we did them all in the right order. If we'd done it in a different order, then we wouldn't have got the same answer, and therefore it wouldn't be correct. Okay, so this is where we've been up to and what we've been doing. So we've looked at areas of squares, rectangles, right angle triangles, and non-right angle triangles. So today we're going to look at area of a kite and rhombus, which is a bit of a different thing to be looking at, really. So here I just looked online to find a picture of a kite, and I found this rather nice jewel here. And we're going to look at how we might find the area of that. Okay, now when we've been looking at triangles, we've been drawing rectangles round them, and it doesn't make sense to try and maybe, like, for example, draw a rectangle like this, because that's silly, that won't work. But what we could think about is drawing a rectangle all the way round the kite so that it just touches the edges here, 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 and here. Okay, so I've done that already, so we can have a look at this. So what I want us to focus on is the bits that we're cutting off. Okay, so if I just go over this top right hand triangle here that we're cutting off, so I'm just doing that. Hope you can see that. So I'll just roughly colour it in like we did yesterday with the non-right angle triangles. So then if I just grab this that I've just drawn and move it to the side, what we can see is if I turn that round, look, it's the same size as that triangle. So the bit that we cut out of here, this bit here, is actually the same size as that there. Okay, so I'm just going to leave that there. The next bit we're going to look at is the left hand side, so this top bit that we would be cutting off here from our rectangle. And again, if we cut that off, spin it round, it's the same size as that. Okay, so this bit here is the same as that bit there. So let's just grab that again and put it right next to that one. Oops. Okay, so obviously slightly off with my drawings because I'm not using a ruler here. Then it won't come as much of a surprise to you, I guess, to know that I'm going to look at this triangle down the bottom here now, this right yellow one at the bottom at the right hand side. So again, just going round that. I'll colour it in to show you that I've got it. Then when we go and cut this out, I'm sure you've kind of got the hang of this by now, but if we spin that round, it's the same as that. So we can put that bit over there. Okay, and then the last bit that we're going to look at is of course this bottom left triangle here, which is the sort of greeny colour one. That one there. And again, if we chop that off, move it out of the way, spin it round, it is the same size and shape. Spin it a bit further. Same size and shape as that one there, so it can fit in there. So basically what we've shown is this right hand scribbly purple kite is what we made out of the bits that we cut off. So that must mean that the area of this kite here is half of the area of the rectangle that goes all the way around. Okay, so this rectangle here, all the way around, that I'm drawing with purple just now. So that rectangle, if we worked out its area and halved it, we would get the area of the kite. Okay, so now we need to think, what are the dimensions of that rectangle then? What's the length and breadth of that rectangle? Well, it's to do with these lines that are drawn in the kite. This one across here and this one down here. And these are special lines in a kite. These are called the diagonals of a kite. Okay, goes from the top to the bottom and from side to side. So they're the diagonals. So the diagonals of a kite or any quadrilateral join the corners that are already joined. So they go right across your quadrilateral. Okay, and so the length of this rectangle, let's do the length across the bottom, sorry. So the length of the rectangle is the same as the length of that diagonal, isn't it? And then the breadth of the rectangle, if we're going to talk about it like that, is the same length as that diagonal. So to get the area of this rectangle, we're multiplying this length by this length, or in other words, this length by this length. So the area of a kite is equal to a half of the diagonals multiplied together. So if we call the diagonals D1 and D2, it doesn't matter which way around they are, of course, when you're multiplying. So it's a little bit like the triangle formula, because what we've got actually is 4 triangles all adding together, isn't it? So the diagonal 1 is one of these lines, and the diagonal 2 is the other one, and it doesn't matter which way round they are. So that's for a kite. Now let's have a look. I'm sure you can tell that if I were to draw carefully a rectangle all the way around this rhombus, if I did what I had done with the kite in terms of chopping off the corners, what we would find is that that rectangle there is the same size and shape as that one there. That's a rectangle, I meant triangle, sorry. And that this triangle here is the same size and shape as that triangle. And the same at the other side as well. So what we've got, again, is that the area of the rhombus is a half of the area of the rectangle all around it. And if we look at the rectangle all the way around it, the length of the rectangle is the same as the length of that line there that goes right across the rhombus. So that's one of the diagonals. And the breadth of the rectangle is the length of the other diagonal. So it's exactly the same for a rhombus or a kite, that the area is equal to, you multiply the 2 diagonals together because that gives you the length and breadth of the rectangle around them, and then you need to half it. Okay, and I've just made a note here that D1 and D2 are the diagonals which meet at right angles. So we're just going to do one example there using that formula, which I'm about to write down again. Okay, so the area of a kite is a half of the diagonals multiplied together. And again, if we want to sort of visualise this rectangle, if that helps, when we're using the formula, then the length of that rectangle is 9. So we've got a half of or times, remember, let's just use times straight away. A half times, so one diagonal is 9 and the other diagonal is 16. Okay, now there's definitely an easier and a harder way to work this one out. Let's not do a half of 9 and then times it by 16. And let's not do 9 times 16 because that's tricky, and then half it. Why don't we do a half of 16, so that's 8, and times it by 9. That's a bit easier, isn't it? Because we know our 9 times table usually. So that would be 72, and it would be square centimetres. Okay, so that's how you find the area of a kite or a rhombus. Now we're going to look at the area of a parallelogram. So what I want us to think about in a parallelogram is it looks like a knocked over rectangle, doesn't it? And if we think about this side of the parallelogram here, let's just think about what would happen if we just chopped that triangle off there. There we are. So I've chopped that triangle right off, and we will find that if we just move that, look, it's exactly the same as that. So what we did was chopped off that triangle, but look, we've added it on there. And what that's given us now then is, of course, a rectangle. So if you take any rectangle and chop a triangle off one side of it, and then pick that triangle up and move it to the other end, then what you've ended up with is the parallelogram. So the area of a parallelogram is the same as the area of the rectangle that you would get if you chop the triangle off and put it at the other end. Okay? There. So, what we're looking at here then is, now I've got to be careful about this, the area of this rectangle is length times breadth. Now, that line there is 10 centimetres, and so is that one, because remember, opposite lines in a parallelogram are equal in length. So that's the length of the rectangle, which is 10. That's the breadth of the rectangle, which is 5. So you just multiply those together. So the area of this would be 10 times 5. We're not halving or anything. So that's 50 square centimetres. And we can see here that we've got a formula. So the area, now a parallelogram doesn't have a length and a breadth. A rectangle has a length and a breadth. So like a triangle, a parallelogram has a base and a height. And that is because in a parallelogram, if that's the base along here, then remember the height of the parallelogram will be at right angles to the base. Okay, it's not the length of that line there. That's not the height of the parallelogram. That is the height of the parallelogram. Okay, so the area of a parallelogram is base times height. And we'll do one little practice of this. And so I've given you more measurements than you need here. So we'll write down our formula. It's a parallelogram, so we're going to use base times height. So we can see the base of our parallelogram is 100. And the height, it's either 50 or it's 60. So we have to use the one that's at right angles to the base. We need that length there that she drew in a very wobbly line. Okay, so that length there, of course, that's 50. It's not 60. So we've got 100 times 50 or 50 times 100. So 100 times 5 is 500. And then times it by 10, so that's 5,000. And we would need square metres because we've got metres in the question and it's an area. So that's all we needed to look at today. So tomorrow we're going to go on to the last bit of area for this week, which will just be recapping everything that we've looked at during the week. Okay, so see you then.